Okay, so in example 5, a couple of things going on here. We have Lx is equal to mx, so Lx and mx. So what I'm noticing is these are segments that go from the center and are perpendicular to these two chords. And if these are equal, if we put tick marks here and here, that means that the green chords are going to be equal as well. Then they also tell us from x to y is 13, and from V to W, over here, is 24. All right, so first thing we're supposed to find is Y to Z from here to here. So we know that that would also be 24 because those two chords are congruent. Then Y to M is going to be, because this is going to be bisected because of that box, because it's perpendicular. This is going to be half of that 12, which is 24. And then MX. Now here's where it gets interesting. MX, I don't know. I also don't know LX, which would be congruent. But what I do have is a green triangle. It's a green right triangle. And I know when I know two sides of a right triangle and I don't know the third side, I can do the Pythagorean theorem to find the third side. So a squared plus b squared equals c squared. Remember, 13 has to go in the c spot because it's the hypotenuse, and b comes out to be 5 because it's a triple. It's a 5, 12, 13. So that tells me that mx is 5, in which case lx is also 5 because those two segments are congruent. And then from L to V is going to be half of that, 24. So it's 12. All right, so pause the video and you try. Okay, so on the you try, we have those two green segments were congruent, and that's all we knew. But because we know that G is equidistant from both chords, then that automatically tells us that these two blue chords are the same length. First thing we're supposed to find is TU. And to find it, we have a yellow right triangle, so Pythagorean theorem. So 3 squared plus b squared equals c squared, so b comes out to be 4. And then TR, if this is 4, the whole thing will be 8. And then CA, this whole side will be 8. And then DA from here to here will be half of that 8 will be 4.